Orion is getting ready to launch. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. For this flight, it's time to head home.
What you see here, this one, is a human cell. This is a human nucleus, so, it's 10 microns approximately. And these two lines that you see here are two iron ions that you don't find in space. I'm sorry, that you find in space, but not on Earth, except in Darmstadt, the GSI, where we have it, going through the cells and making damage to the DNA.
NASA will also be monitoring Orion's navigation systems and its resilience when traveling through high radiation areas. 3 mannequins on board will be fitted with sensors to determine how astronauts will fare on the flight.
Biosentinel, a shoebox-sized CubeSat, is one of several secondary payloads on our uncrewed Artemis 1 flight test. It will perform the first long-duration biology experiment in deep space by monitoring the vital signs of yeast exposed to deep space radiation. Yeast cells have some biological similarities to human cells, so Biosentinel could help us better understand the risks of space radiation to humans and other biological organisms as we plan crewed exploration missions to the moon and beyond.
I love the fact that they have to put mannequins in those seats. It puts things in perspective.
Yeah.
Well, yeah.
Because it's never been done.
Well, we did go to...
I was supposed to give ideas here. It looks like, radiation is a problem. This is clear. Shielding, passive shielding can be a solution on the planet, but not really on transit. Maybe the best solution, the best idea is to use a magnetic shielding, is to build magnetic fields for the spacecrafts that can do what is done on Earth. So it's not really a new idea. It's the same idea that God had a few billions of years ago when he said, okay, I want to make life, but I created radiation already. What can I do now? Okay, maybe I can make a magnetic field,
This is the entirety of the Earth's atmosphere, consolidated to showing all layers, including the tropopause, the mesopause, stratopause, the mesopause, so on and so forth. This explains the temperature differences between each of those points. This here represents the entirety of the Earth's magnetosphere and the various bands within it. The blue within the plasmasphere right here represents all of the entirety of Earth's atmosphere. Earth's atmosphere stops at the end of the blue and is only confined and contained through the magnetosphere. As far as we can go is 230 miles. The end of the atmosphere is 6,213 miles out. That is just the end of the blue right there. So, we can't just go up and out, or you're going into 100% of that 1% that we get 1% of. So within that 1%, of that 1%, into that 100% is certain doom. That's why we have to stay safely here within the layers of atmosphere that are still filtering us, within all the passive shielding we can take up there, very, very safely within all of Earth's active shielding. The moon is the size of the tip of my pen, and it is 230,000 miles out. 230, now remember, 620. This is 25,000 kilometers, or 25,000 miles out. So if the moon was, say, back here, and we could go all that distance, it would be here. This is where the moon would be. This is why we can't leave Earth, and this is why they don't worry about climate change.